So now we come to the distance formula. Oftentimes the distance formula is presented to students and they're told to plug the numbers in and practice it, but our approach is the exact opposite. At this point, the students should have discovered the distance formula, even if they haven't done the formal language and the symbolism at this point. Essentially, if they've done the previous work with finding the distance between points visually, and they've been using the Pythagorean theorem, that's all the distance formula is. It's just using the Pythagorean theorem. So in a way, you don't really need the distance formula. If you understand how to find the distance between points, you can just always use that. So really what this is a formalization of the ideas that students have already discovered for themselves. We're just helping students put into symbols the ideas that they have already discovered. To help students derive the distance formula, I'll often start with a numerical example, and we'll talk through the process. That's what's really important, not the outcome of what the distance actually is, but what are they doing to find that distance? If students can articulate that, then really that's the formula. That's just the process. So let's do a numerical example, and I'll talk about how I would help students get to this point where they can now do it totally symbolically. So here we want to find the distance between the -1, 2 and 8, 3. And so I would talk with the students about what they do. So they say, well, I would find the third corner of the right triangle and say, okay, well, how do you know where to find that? How do you know where that peg is going to be? And they've probably just been doing it visually at this point, but we want them to be aware that this point is directly above this one down here and across from the other one. So we say, what are the coordinates of that point going to be? And they're going to be -1, 3. And how can we figure out what those coordinates are? By just looking at these two coordinates. If we didn't even do this on the coordinate plane, what's similar about these? And students should say that it has the same x-coordinate as this point because they are vertical from each other, and it's going to have the same y-coordinate as this point over here. And that's where these coordinates come from. They're not just randomly out there. They're related to these previous 2 points. Okay, so what did students do next? Well, they want to find this long distance here. And so now they want to find the vertical distance and the horizontal distance. And by the way, I always do the vertical distance and horizontal distance in that order, just because when we do slope, we do vertical and then horizontal. So it's kind of just an indirect way to prepare them for the idea of slope. Doesn't have to be done that way, just something that you can throw in there. Anyway, we find this distance here, and that's going to be a distance of 5. And I can ask the students, well, how do you know that's 5 besides measuring it? How can you look at these coordinates and tell that they're 5 away? Well, we want to know how far apart 3 and -2 are. And whenever you want to find out how far apart 2 numbers are, you want to find the difference between them. And the difference is by doing subtraction. So this is something hopefully students discovered earlier when they were finding the distance between horizontal and vertical points. But we can bring that up here and formalize that a little bit more. So this 5 we get by taking 3 and subtracting -2. So 3 take away -2 is 5. And I might even label that here. Instead of labeling it as 5, I might label it as what it is the students are actually doing. So here's the answer, and here's what we did to get the answer. How about for the horizontal distance? Well, that's going to be a distance of 9. And what can we do to calculate that distance? Well, we can find out how far apart these x-coordinates are. So if we subtract 8 minus -1, that's going to give us +9.
And what's our last step? Once we know these two legs, we can put them into the Pythagorean theorem to find out what the hypotenuse will be. And when we do that, we get the square root of 106. But how did we get that 106?
Well, we took the leg squared plus the other leg squared. In this case, that was 5 squared plus 9 squared. And we can even talk about how did we get the 5 and the 9? We got the 5 by doing 3 minus -2 and then squared it. And we got the 9 by doing 8 minus -1 and squaring it. So now we can do an example where we take away all the numbers and we do it just symbolically. We do it all abstractly, but it's the same concepts that we've been talking about and the students have been doing over and over again. So let's see what that would look like. So what I would say is, I'd say, well, let's just put 2 points anywhere. I'm not even going to find out what the coordinates are. I don't care what these numbers are here. We just have this first point and this second point. And so we're going to call that x1, y1, or x sub 1, y sub 1, and x sub 2, y sub 2. If students have done the midpoint work before, they already know what those subs mean, and they're a little familiar with that. If not, then we can just introduce that at this time. So then we say, all right, we make our rubber band, we want to find the distance. We then have to find the third vertex. And what's that third vertex in comparison to these points? Well, it's going to have the same x coordinate as this point is, and the same y coordinate as this one. So whatever x coordinate this is, here we're calling it x sub 1, that's going to be the coordinate of that. And whatever the y coordinate of this point is, that's what we're calling this here. So this stands for the same height and the same distance over, and then we make our right triangle. And it doesn't matter what these distances are at all, but how do we calculate that? Well, we calculate this distance by finding the difference between the y's. We subtract those from each other. We've been doing that the whole time. We've taken the y coordinate minus the other y coordinate. And how do we find this distance? We find the distance between the x coordinates. That would be x sub 2 minus x sub 1. And then we want to find this distance here, that's d. So how do these three sides of the triangle relate? Well, we know that the hypotenuse squared, which is d squared, is equal to this leg squared plus the other leg squared. And so we just have the Pythagorean theorem. That's all this is. This leg we got by finding the difference in these x coordinates, and this leg we found by finding the difference in these y coordinates. And if we want to, we could also write it like this, solving it for d. That's also a common way to see it, where you find the distance directly. And this is the beauty of working with this material. It's that this is something the students can discover. It's very natural. In a way, there's nothing new here. I mean, you look at all these letters and all this stuff here, and it can be just overwhelming. But it's not if we present it the proper way, if this is really a discovery that the students make. Furthermore, students don't have to memorize this formula. They're just using it naturally. And so it's something that, again, if they don't use it for a while, how are they going to remember that? I mean, I can barely remember it, but I can always reconstruct it because I can say, oh wait, it's the Pythagorean theorem, and how do I find the signs? And students can redo that work. And then when we have two formulas that look very similar, like this distance formula and the midpoint formula, like here they have x1, one has pluses, one has plus but the minuses. They're in different orders, one has subtraction. Like, how would you know just randomly which one is which, and you could recall that? But if we look at the midpoint formula and we say, oh wait, that's just the average, then it's very obvious that it's adding and dividing by 2. And if we say, oh, this is just the Pythagorean theorem, then you know that you're squaring and that you're adding those together and that you're finding those differences. That's really all there is to it. And so this is a great culminating activity. It can be done with students from a very young age. Once they know how to plot points and they can find the distance between points vertically and horizontally, then all this work is just using the Pythagorean theorem in a new and exciting and different way. So that's all there is for the distance formula.